All right, so we're going to talk about solving inequalities. So there are four inequalities that we're going to deal with here. So we have greater than, less than, greater than or equal to, or less than or equal to. So if you remember greater than or less than they're strictly greater than or strictly less than, what we're going to use is we're going to use a circle on the number line to graph these. And with these, we're going to use a filled in dot, okay? So we want to be able to write an inequality. So this says 5 fewer than a number is at least 12, okay? So let's take this first part right here, 5 fewer than a number, okay? So I know a number, I'm going to say n minus 5 at least 12. Well, what does the word at least mean? It means that it has to be 12, okay? So it has to be 12, and then we're looking at least, so it means bigger. So it has to be bigger than or greater than or equal to 12. Okay, so that's kind of writing out that inequality. Now we're going to talk about properties of inequality. So a lot of the same properties hold true from regular equations to inequalities. The first is the transitive property. Transitive property says if A is greater than B and B is greater than C, then A is greater than C. We have addition. So if A is greater than B, then A plus C is greater than B plus C. And our example of that is 4 is greater than 2, so 4 plus 1 is greater than 2 plus 1. And you can see the example there of the transitive. Subtraction, if A is greater than B, then A minus C is greater than B minus C. 7 is greater than 4. So 7 minus 3 is greater than 4 minus 3. Right? We can see that. That's 4 and is greater than 1. Now multiplication and division are a little bit different. But now we're going to look at breaking that up into two pieces. Okay? So you notice here in our definition of multiplication, we have C is greater than 0 and C is less than 0. We don't have equal to 0. The reason we don't have it equal to 0 is because 0 times a number is going to give us 0, and that would maintain equality. So here's the first one. If A is greater than B and C is greater than 0, okay, then AC is greater than BC, right? So C is greater than 0, that means C is a positive number, okay? Our example here is 6 is greater than 5, 3 is greater than 0, so 6 times 3 is greater than 5 times 3. 18 is greater than 15. Now, we have a second part to that. What happens when C is negative or less than 0? So if A is greater than B, C is less than 0, then AC is less than BC. So now we're going to be multiplying by that negative number. Here's our example here. 3 is greater than true. That's a true statement. Negative 4 is less than 0. So 3 times negative 4 is less than 2 times negative 4. So this gives us negative 12 is less than negative 8. And that's a true statement. Okay? So division has that same type of inequality where if C is positive, so if A is greater than B and C is greater than 0, then A over C is greater than B over C. Here we have our example here. 9 is greater than 3. 3 is greater than 0. So 9 over 3 is greater than 3 over 3, right? 3 is greater than 1. And now we're going to look at what happens when C is less than 0. So if A is greater than B, C is less than 0, then AC is less than BC. Here's our example here. 12 is greater than 6. Negative 6 is less than 0. So 12 over negative 6 is less than 6 over negative 6. So this over here gives us negative 2 is less than negative 1. That's a true statement. So when you're multiplying or dividing by a negative number, you're going to change the direction of the inequality. Okay? So if it's greater than, it becomes less than. If it's less than or equal to, it becomes greater than or equal to. Okay? So we're going to look at solving now inequalities and graphing them. Okay? So the nice thing is a lot of the same properties hold true. So we're going to be able to work on all those. So here I see that I have negative 3 times the quantity 2x minus 5, quantity plus 1 is greater than or equal to 4. So I notice here that there's a distribution, so I'm going to take care of that first. So I'm going to go negative 3 times 2x, that gives me negative 6x. Negative 3 times negative 5 is 15. Plus 1 is greater than or equal to 4. I'm going to combine like terms. Okay. So I added my 15 and my 1. And now I need to isolate my variable, just like an equation. So I'm going to take this 16, I'm going to subtract it over. Minus 16, negative 6x is greater than or equal to negative 12. Okay? So now I need to go ahead and finish off my last part here. Erase this so I have more room. And I'm going to divide by negative 6. So since I am dividing by a negative number, I have to change the direction of the inequality. Okay, so division said I divided by a value less than 0. I'm going to change that inequality. So x is now less than or equal to 2. There's my value that makes that a true statement. Okay. So I just moved this over here. So here's our next problem here. So we're going to look at going ahead and solving this one also. So I'm going to distribute my negative 2 through. Negative 2 times 3x is negative 6x minus 2 is greater than negative 6x plus 7. All right. I have variables on both sides, so I'm going to go ahead and add this over. Negative 2 is greater than 7. What does that tell us? Does it tell us anything? When can negative 2 be greater than 7? Well, this is not a true statement. Okay? So that tells us there is no solution here. There is no value of x that's going to make that a true statement ever. Okay? Kind of like when we were solving equations, we had infinitely many solutions or no solution. So this is a no solution here. So we're going to look at our next one here. We're going to distribute my 5 through here. 10x minus 15 minus 7x less than or equal to 3x plus 8. Okay. So I'm going to go ahead and simplify here. So I have 3x minus 15 is less than or equal to 3x plus 8. So I combine my 10x minus 7x. I notice that there's a 3x on both sides, so I'm just going to subtract that out. And I get negative 15 is less than or equal to 8. Well, that's always a true statement, right? So since that's always a true statement, I have infinitely many solutions. So this is a thing where all reals is a solution. It works for every single value of x. The last thing we're going to talk about is compound inequalities. So what is a compound inequality? A compound inequality is when we have 2 or more inequalities together. Okay, usually connected by the word and or the word or. Okay, so our first one looks like this. 7 is less than 2x plus 1. And 3x is less than or equal to 18. Okay. So we're going to go ahead and solve these and then graph them. I forgot to graph over there, but we'll pick that up here. So the first one, I'm going to go ahead and solve this. Okay. So I only have one variable, so I'm going to isolate it. I'm going to bring my 1 over. So I'm going to subtract 1. 6 is less than 2x. I'm now going to divide by 2. I divide by 2, divide by 2. I'm dividing by a positive number, so I don't have to change the inequality. X is greater than 3. So I'm going to come over here. I'm going to start my number line. 1, 2, 3, 4, 5, 6. 9. Keeps going. Negative 3, negative 6, negative 9, and it keeps going that direction. So here I have strictly less than. So over here, these would be open. I put those on a graph, and these would be filled in. So I'm going to use an open circle. Okay, so I'm going to go over to 3. I'm going to draw an open circle there at 3. Okay. Now, it says x is greater than, right? So I always typically read it with the variable with regards to the variable. So x is greater than 3. If I read it left to right, this would be 3 is less than x. But to help me understand graphing, I always read it variable first. Okay? And I can flip these around also to help me. X is greater than 3. So the values greater than our 2 are right here. Okay? So those values go that direction. Now, we're going to take our orange marker here so we can kind of look at the comparison here. So now I have 3x is less than or equal to 18. So I'm going to go ahead and divide by 3. So x, I'm dividing by a positive number, so the inequality stays the same. 18 divided by 3 is 6. So I have x is less than or equal to 6. So I'm going to go over to 6, and it becomes a filled-in dot here, and it says x is less than. So the values that are less than are to the left. Okay. Now, this says it's an and. Okay? So an and means it has to satisfy both of these inequalities. It has to be less than or equal to 6 and greater than 3. So my actual graph is going to be the joining of those. Okay, so this piece in green from the open circle at 3 to the closed dot at, oops, and I put that at 7. Six. There we go. And so that gives us our graph there. Now the next one is an OR. And what does OR mean? Well, OR means that it only has to work for one of the inequalities. It doesn't have to work for both. So I have 7 plus k is greater or equal to 6. Or 8 plus k is less than 3. And we're going to solve both of these. Okay? So I'm going to start with my orange here. I only have 1k, so I'm going to isolate it. So I'm going to subtract off 8 from both sides. K is less than negative 5. Okay? Put this number line in blue so it's a little easier to see. 0, 1, 2, 3, 4, 5. Here's negative 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it says I am less than 5. So I'm going to put less than negative 5. So I'm going to put an open circle here and go that direction. Okay, so less than. So now I'm going to go ahead and solve the blue equation here. So I'm going to take 7. I'm going to subtract it over to the other side. K is greater than or equal to negative 1. And so I'm going to go to negative 1. I'm going to put a filled in dot here. It says K is greater than or equal to, so I'm going to go to the right here. And that's my graph. It's going to include both of them. Okay? So when you're working on these first ones here, you're only going to have one direction. So I get my graph here. 0, 1, 2, 3. Okay, so I put my solid dot at 2. I'm only going to go one direction, to the left. Okay, so that's solving inequalities.